Okay, everyone, time to get started. Everyone want to give a quick shout out and we can get started. Hey Chris, hey Drew, hey Sivan.
Good morning.
Morning all. Ian is here.
Or I guess evening for you, huh?
Oh yeah. Morgan is here. All right, everyone. All right, let's get started. So, I thought of doing today's topic based on something we did a couple of months ago. Drew is aware of this. We were working on the Open Hardware Summit wrist badge, and there were some things I learned doing that, which I thought should be helpful for anyone else who wants to do some best practices in KiCad and FreeCAD projects, especially with regard to board outlines and component placements. So let me fire up KiCad to start with. Howdy, Morgan. Here's my KiCad. So let me first try the project that we did. I missed screen sharing, so here goes. Share my screen. Screen share. Oh, KiCad 3. Options. Okay, so this is the Open Hardware Summit 2020 badge. Well, the summit didn't happen, but badges did happen. Let's see, where am I stuck? Okay. Let me get my mouse set up. So this is the Open Hardware Summit badge that we designed a couple of weeks ago. The units are physically lying at Summit in New York at the moment, since the summit got cancelled. So, but while working on this, at least I learned a couple of things. And let me first show you the problem as I saw it. Here's the board layout. And I'm not sure, but maybe Drew can correct me on this, but it was possibly Michael Welling who did the initial layout and the board, let's say, mock-up in terms of size and shape. So my guess is he probably made the outline in something like Inkscape, and then tried and imported it into KiCad. And the process works. I wouldn't say that it's wrong or incorrect. It works, but it resulted in a lot of issues which, uh, on hindsight, could have been avoided. But as far as this project goes, it all worked out, so that was nice. So here's the problem I see as it happened. Let me show you the footprint editor. Get at the issue. Here it is. Here's the library top. So when you import a DXF file as an outline in KiCad, one of the things that happens is that the arcs and circles get replaced with linear line segments. And this means that you lose information on certain important things like where is the center of this particular circle or where's the center of this arc. So without that, once you try and get things from KiCad into FreeCAD, let's say to design enclosures or do any mechanical work, the lack of that information becomes pretty apparent, because if you can't fix precisely the center of the circle, it becomes difficult to design, an enclosure around it, for example. So, the other thing is, because the arcs and circles get broken up into line segments, once you bring it into KiCad, it might become difficult to move the whole edge cut outline layer as one unit without first having to actually hide all of your layers and turning off the layers that you don't see, then grabbing all the elements on edge cuts and moving them. So that becomes a bit difficult, which is why I'm guessing what Michael did was a smart thing, actually. He converted the outline into a footprint, and this is what you see here in the library. Once you scroll down to the badge library and you look at PCB top, this is the footprint for the edge cuts layer. Frankly, this is the first time I've seen anyone actually do something like this, is to have the edge cuts layer as a footprint. And here's where the problem comes. Here's a circle, and you can see the circle has been broken down into line segments. Same thing for the corner fillets. And that means I can't really get the center point of these mount holes. The other problem that happened was, that's the origin point, 0, 0. And with respect to that, the whole footprint is neither aligned in the x-axis nor the y-axis. And the origin point is actually somewhere outside of the whole footprint. That created a lot of other problems. For example, if you look at the position of this vertical edge, you'll notice that its location is a number down in the nanometer range. It's in the x-axis, it is 1.705909 nm. And obviously that makes life very difficult when you move things to CAD. Same thing applies for the other edges. Really funky position values for all of them. So that was the other problem that I foresaw with this approach, is that the origin was not fixed with relation to the actual outlines. So that's what I thought. Let me see how we can design footprints that retain information such as the center of the circles or the center of the arcs, even if you draw it in a CAD program like FreeCAD and then bring it into KiCad. So if you've drawn a circle in FreeCAD, it needs to be imported into KiCad as a circle too. That helps. And in order to do that, let me start off with a simpler project. I'll come back to this later to see how we can change this whole thing to a more reasonable outline. But for now, let me close that and open. Let's go into recent nightworks. So this is a project I helped a friend of mine. The final version was a bit different, but this was a voltage regulator boards, which clips on top of 9-volt batteries. So this was done by a friend of mine, Mahesh, at Electronet Labs, and his idea was pretty brilliant. 9-volt batteries are quite common in India, and to get either 5-volt or 9 or 3-volt 3 from a 9-volt battery, his idea was to make a small board which is the same cross-sectional size as a 9-volt battery, and it clips directly on top of the battery. And then you can get 5-volt 3-volt 3 output from it. So the design is pretty textbook simple. There's a regulator, a couple of voltage setting resistors, and an LED for indication, and a pair of capacitors for filtering. This is what the PCB looks like. It's 26 mm wide by 17 mm tall, and let me show you in the 3D view. Yes, so this is what it looks like. At the bottom, you plug in a 9-volt battery, and from this header, you can get either 3 volts or 5 volts. So this was the idea, but I thought let me use this as a way to show how you can make a complex shape for this particular board. Now here's a use case. Let's say you want an edge cut that is a pentagon with rounded edges. Clearly it is not very easy in KiCad. Uh, KiCad only allows you to draw straight line segments and arcs, and you can't set start and end coordinates for lines easily. So that makes drawing a pentagon in KiCad extremely difficult. So the way you can do it is what we're going to look at now. Let me close this for the moment and fire up my FreeCAD. Let me try the Snap version today instead of the install FreeCAD 19. Here goes. All right, if I have audio issues or someone can't hear me, please unmute your mic and let me know. But otherwise, since everyone's quiet, I'm assuming things are going smooth. Okay, so here's FreeCAD. What we're going to use is something I talked about earlier as well. It's a workbench known as KiCad StepUp. If you don't have this in FreeCAD, you install it by going to Tools, Add-ons Manager, and if you scroll down this list, somewhere down below, you'll find KiCad StepUp tools. So just install this, and you should have the workbench. It looks quite busy with lots and lots of icons. So if you want to have a quick look at what it does, click on push-pull and click on KSU Tools. And under Demo, you'll find a cheat sheet. That's kind of pretty handy. So this can give you a quick tour of what this workbench can do. And I recommend you take a look at that. The other thing is, this icon which says activate the main KSU StepUp Tools dialog. Doing that brings up this dialog. It's a smaller subset of all of these many icons over here, and is some of the most commonly used functions within KSU. So this is handy to have separately. If you'd like to move this around, I usually prefer throwing it over here like so, so that I can have the combo view and the tools both at the same time. So that's useful. All right, so we have FreeCAD running, we have KiCad and that's done using this icon that says load a KiCad PCB. So here's the nice thing. You don't have to export from KiCad to do this. KSU Tools handles this for you directly. So click on this icon on desktop, project, KiCad. Here's the PCB. So there it is. It takes a while for all the parts to be populated, and we have this nice PCB out. Oh yeah. If you go to the tree view for this project, uh, it starts with this 9-volt snap, and you'll find two main groups over here. One is step models, which is obviously each of these step models that you see here for resistors and the voltage regulator and the header and so on. So that's one group, which at this time we really aren't concerned right away. And the other is board geometries. When you expand that, you'll see the PCB compound. If I press the space bar, I can hide the PCB and I can unhide it. And right below the PCB solid, you'll find a sketch with the same name that's hidden right now. This is the edge cuts outlined as a two-dimensional sketch. So when you double-click this, you get your whole you get the PCB in sketcher mode. But let me close this and hide the things we don't need. So we don't need any of the step models. I select the step model group and press the spacebar to hide all of them. I hide the PCB by again pressing spacebar on it, and then I double click on the PCB sketch. So here's the existing sketch, which as we saw was 26 mm wide and 17 mm tall. And like I said, let's assume that we want to make this into some kind of a pentagonal shape. So the sketcher tools allows you to make a new sketch. To start with, since I want my pentagon to be centered around this existing rectangle, I'm going to draw some reference construction lines. So that is done using this, highlighting this tool. So that changes all of their construction lines, like so. Then I draw a vertical line and a horizontal line. Let me chop off the excess from the top and the bottom and from the two sides, like so. Then let me see if I can make this. I choose these 3 points and make sure they are, oops, just easier to set the distance for the moment. So this was 26 and half of that. Try again. This point, horizontal distance 13 mm. So that's, yeah, pretty much in the center. And this one to this horizontal line was 7, half of 17, that's 8.5. So that's 8.5. So I have this center point here now, which I can plonk a point there. So I get a reference point right at the intersection of these two lines. So with this, I am now ready to make a new outline for this board. So I get out of construction mode. In the polygons, I can select a pentagon, choose the center of the pentagon at this point at the center, and then stretch it out Okay, so here's an approximate pentagon. If we make the base horizontal, so that's done using the horizontal constraint. Let me add a radius to the circle so I know what's the size of the pentagon. So radius 24 mm. And yeah, so that's pretty much, oops, yeah. So that's your pentagon. I can probably get rid of the old rectangular outline now. So let me just delete all of that. I'll miss some of the, okay. So I'll set the center point of this pentagon from the vertical x-axis at 13 mm. That's it. Another 6 degrees of freedom. This is degrees of freedom that you see here. That tells you how many uh, okay, I need to set the vertical as well. So this center point from the horizontal x-axis was 8.5. This has another 5 degrees of freedom. I don't need these. Oops, keep hitting escape. I don't need these lines anymore. So I have a constraint sketch. I have a pentagon that is centered around the center of the old PCB outline. Uh, it's enclosed within a circle that's 24 mm in radius, and it's fully constrained because now the 5 lines of the pentagon have turned uh, green. Now, let me add fillets to this. Like we said, we want to have a pentagon with rounded edges. So here's the fillet tool. Once we do that, we're going to have to add more constraints because now the constraints are lost. So that's one. That's another. Just a fillet here. Add the third fillet. Add the fourth one, and finally add the fifth one. So 5 fillets. I want all of them have the same radius, so I select all 5 of them. Control key to make multiple selections. 5. Select the radius. Constraints say yes, you want all 5 to have a common radius, and give it a number of 6, 7. So I now have a pentagon that is got rounded edges, but things aren't really equal. There's still 5 degrees of freedom that are not fixed. So let's try and set that. What I need is to have this to tangent these two tangential. This one tangential over here. 3. This one tangential here. 4. And last one over here. Make this tangential to this. There you go. So we now have a constrained circle, pentagon, enclosed within a circle with the enclosing circle having a radius of 24 mm. That's this, and the edges with the 6 mm fillet. That's our new outline for this board. I can close this, and if I unhide the original PCB compound, you can still see it's the old dimensions and size, but we have the new sketch here. The next step is to push this outline from FreeCAD to KiCad, and this is where things really shine through. Uh, on the toolbar, you see this icon that says push 3D moved, sorry, this one, push sketch to PCB edge. So choose that. We want to put it in the edge cuts layer with a width of 0.16 mm. Say OK, select your board, save, say yes. So we now have the new edges pushed to the PCB that we had earlier. Once you say OK, I can then go to KiCad, open the PCB, and hopefully there it is. This has the pentagonal outline now with rounded vertices. If you take a view in 3D, you can see here's a pentagon now. And this is where things are better compared to DXF import. If I choose this arc, it's no longer a series of segments. It's an actual arc whose center point is over here, which means I can grab dimensions. Let's say if I try to make dimensions from the center of this arc. There is a way to do that, but it should be 6. Oops. For the end point of the arc. What's the grid? No wonder. I need point 1. Okay, can't get that, but the reason is if I check this line and its properties, you can see the numbers are the y-axis. It's 29.062, which is why. So I need point not 1 grid, which I will have to set, which can't do right now. So what I could have done, which I didn't, was move this whole thing, move this whole pentagon, and instead of having chosen the radius of the enclosing circle, I probably could have chosen the length of the side as a defining constraint. But or I could have moved the pentagon to the center of the XY coordinates. That would have made things easier for sure. But essentially, this is how it is. You can get outlines and edges, which are true arcs and segments lined instead of segmented arcs. That can help you with neater and cleaner edge cuts. Let's say you want to add mount holes over here. So we can go back to close this, go back to our FreeCAD, go back to our sketch, and drop a few circles here at the center point of the arcs like so. Make these two center points coincident and make the radius of this circle 1.67 so you can fit a 3 mm screw in it. Just add one for the moment, but you could have added a hole at each corner. So there it is. You go back to push the sketch to the PCB edge. Okay, choose your PCB, save, yes. Okay, and then you come back to KiCad, fire up your board, and you should have the mount hole over here, which you can see here in 3D. Oh yeah, that's my 3D one. There you go. And then within KiCad, you can locate the center of this PCB of this circle. So, any questions up until now based on this process? Because it's quite easy, and you actually can move back and forth between KiCad and FreeCAD in real time. You can adjust and trim the outline layer with great precision using this this technique.
I have a quick question.
Sure, go.
By the way, this is amazing. This is something I can use today. So thank you very much for showing how to navigate between these two.
Right.
For construction lines in FreeCAD, if there were some of those construction lines that we wanted to carry over into KiCad, let's say in the drawings user layer, is there a way to export to a specific layer, or should we just export it as outline and then in KiCad change the specific outlines back to whatever layer that we want?
I think I'd go with the latter option.
Okay.
We can check. Let's see. Here is let's say we're trying to push an outline. We can actually choose a layer where we want to fill it. So here it is. Yeah. But it will then export everything to that layer. So you can choose to send everything to one particular layer. You can't selectively say send some lines to edge cuts and others to comments layer, for example. So maybe the easiest is just put it all as edge cuts, and then in KiCad it's easy to just swap out a line like this.
Perfect.
And just send it to a different layer from edge cuts, send it to margin or whatever. So, but yeah, it still works. You can bring reference lines. That's a good. I haven't used it, but that's a nice thing to know actually. Awesome. Any other questions at this time? Once you know it, the process is pretty nice and simple. So I'm guessing everyone would like to try it out sometime soon. So here's the nice thing. This way you can make really complex shapes without having to worry about DXF export and import into KiCad. You just do everything in Sketcher, and the Sketcher tools in FreeCAD are really powerful. You can do all kinds of things. You can do circles, ellipses, you can do B-splines, you can do, well, of course, rectangles and polygons, pentagons, heptagons, octagons, stuff like that. You can make ovals, which are different from ellipses, and so on. So, and you can have precise measurements for each of the elements that you're drawing. So you can make constraint sketches. You can also have parametric outlines. So if you use a spreadsheet to enter numbers, you can use those to change the dimensions of your board. Let me see if I can quickly show you. So the way parameters work in KiCad is, in FreeCAD is you open up a workbench called spreadsheet, and here's a new spreadsheet icon. Create a new spreadsheet that comes up in your tree, and when you open up, here is a very rudimentary spreadsheet. It doesn't have a lot of math functions, but most of it. Let's go back to our board outline and see what constraints we have defined. And I think I remember there were two. There's one, which is the fillet radius for the corners. That was 6 mm. and the other one was the radius of the circle inside which the pentagon was put. That was constraint 24. So let's say we want to parameterize these and change them at will, maybe even the mounting holes. So there are three parameters. We start off with defining them in the spreadsheet. We can start off with the radius polygon. The next one was radius of the fillet. Third one is radius of the mount hole, MTG. So these are our three, let's say, parameters. We enter a number for each. Let me enter the existing numbers. Radius of the polygon was 24 mm. Radius of the fillet was 6 mm. Radius of the mounting hole was 1.6 mm. And in order to use these numbers, we have to now provide aliases to them so we can refer to them when we want to use those numbers. The way you do it is click a cell, context click or right click, go to properties, and you'll find a tab that says alias. So put in an alias over here. I can put R poly. You can use the same names as you have defined in the column A, or you can use something shorter like this. So there's R poly. You'll notice this cell now turns yellow, which means it has an alias that can be called in the sketcher. So radius fillet. Another. Let me add an alias to that. Alias. This is R FI for the fillet. And finally, a property for the mounting hole radius, give it an alias of R slash underscore H hole, mount hole. So we have these three parameters set up, and we can now use those within our sketcher. The way you do it is, here's an existing radius, but this is not parametric, it's just a number. So I double click on it, and when you get this dialog box, you'll find a symbol that says FX here on the side. That means a formula. Click on FX, and this is where you can type in a reference to your alias in the spreadsheet. It's easy. If you type S, it gives you a drop-down list where you can drill down and select spreadsheet, and then you say R. You get all of the radii that you selected. So we want the radius of the polygon, R poly. You can see the result now changes to 24. We say okay, okay. So this now, instead of being a yellow constraint, it becomes an orange. Then the color changes. I'm not too certain if that happens. Next thing is to change the fillet radius. So we select that, select FX. In the result, just start typing SPREAD. If you type S, you already get it. Spreadsheet dot R underscore fillet. Okay, okay. So that's your 6 mm for the fillets, and finally the 1.6 for the mount hole. So double click on that, click on FX, start typing spreadsheet R underscore hole. Okay, okay. There it is. So we now have a parametric outline, and so here it is. That's defined. Now let's say we want to change numbers. Instead of the 24 mm radius, let's say we want to have 18 for some reason, 18 mm. Go back to 9 volt, and you can, I think you can visibly see that it's become smaller, right? It's kind of difficult to see this in real time, but let me make a really large radius so it becomes really apparent. So spreadsheet, radius of the polygon, 40 mm. So that's the bigger PCB with the same fillet radius of 6 mm, and here's a smaller one with the same fillet radius of 6 mm. We can also change the fillet radius, which is 6 mm now. I can make it a really small value like 1 mm. 1 mm. Hopefully, yeah, here you go. This is the 1 mm fillet radius. You can see some things go crazy because we haven't added a lot of, let's say, math to check for conflicts. So here uh, the mount hole is larger than and extends beyond the edge cut. So with some amount of functions, you can add in uh, a way to make sure that this circle scales in relation to this arc, for example. So let's say it's a function of this arc. It's let's say the mounting hole is always half the radius of this particular corner fillet that you use. We can try using that. I haven't tried that in a while, but let's say this one is equal to 1. This one is equal to this divided by 2. Oh, that didn't work. Oh, no, this one. Delete all of this. This one is equal to B2 divided by 2. Yeah, there you go. So I just put a cell reference uh, and the alias went out. Yeah, to get the alias back. Let's go. There you go. So now the mounting hole will always be scaled in relation to the fillet radius. So let's get back to 24 mm here, 6 mm here. So the mounting hole will be a 3 mm radius. So that's parametric, kind of pretty useful if you start doing complex shapes or fancy outlines, for example. Questions?
Hi Anul.
Hey.
Uh, I have a suggestion. So I was just playing along at home, and Chris asked a question earlier, in which he said, "Can we move different sketches to different layers?" So I was just playing around with that, and I had some success. If you want, I can just go through that.
Yeah, sure, of course.
Okay. So what I did was, uh,
You'll have to
maybe it
share
would
screen
be,
though.
yeah, yeah. I'll do that. Okay. So, can you see the screen now?
Yeah.
Okay. So I just took one simple board that I have. Uh, Let me open the original project. So it's just this simple rectangle PCB with 22 by 10.25 uh, uh, millimeters, and I just copied it in a different place so that I can play around with that. And I imported that into KiCad, and over here I just moved one of the vertices around, and then I was able to export it to the edge cuts layer using the push sketch that you see here. Uh, so that worked really well. Then what I did here was I just copied this and then pasted it here using this paste button. And then I made some changes to this. I just added some fillets, and then I clicked here, and then I pushed the sketch again, but this time I pushed it onto the drawings layer as a reference. So now when we do that on my drawings layer, I have the another copy with the fillets. So I hope that this can also serve as a really good way of exporting sketches on different layers. So yeah, just wanted to share
Awesome.
that.
That's fantastic. Yeah,
Yeah.
this is what gets me excited because
Yeah.
once you can get KiCad and FreeCAD working seamlessly with each other like this, things are
Yep.
so much more easier for all of us. So awesome. Thanks for
Yep.
checking that out and doing a quick short demo. Any questions, anyone, at this
Yep.
point?
No question, but thanks. That's great.
All right, awesome. So now let me go back to the Open Hardware Summit badge and show you what kind of troubles we, at least I faced. Like I said, it's not a critique of what was done because it was a race against time. We wanted to get the thing done, and sometimes whatever works works. You don't really care about if the process is right or wrong. So it worked out. The badge came out, but as I showed you, let me share my screen again. Whole application, share my entire screen, share like this. So here, this file, extend, here's the badge, here's the badge. So here's the paste ID. Yeah, here you go. So the flip side of having one done the outline in let's say Inkscape or whatever was used, and then pushing it here as an outline was the DXF caused arcs to become segments. That was one. Second thing was to convert the whole outline as a footprint. And having an origin at a point like, let's see, if I select this edge, you can see the outline is somewhere over here where my mouse is hovering. It's outside of the board. So these two things were not really the way you would like to do things in KiCad. If I move this board edge now, you can see it. It's a locked piece, but this is how it is. So that's the whole board edge. And if I select, let's say, one of these edges and look at its dimensions, you can see the XY position is some really vague numbers and values, which means that any placement you do, for example, the USB connector also has some really weird position numbers. In this case, it isn't really too bad. It's 0.001 resolution. But in some cases, some of the numbers here turned out to be really, really weird. And when you are trying to place the parts that are going to interact with the person using the board, so stuff like connectors, display, buttons, sensors, pull up the 3D view. It's easier to see what parts you're talking about. So here one, these four buttons, there's a sensor over here, the display. On the back is the USB connector. There's also two JST connectors, one for the I2C, one for the LiPo battery. So if you want to design a nice case around this, it really helps if you can have those parts at some nice round XY coordinate locations instead of having them in nanometer resolution. So one of the things I did was, and actually I haven't done it, I thought we could try it live over here today, is I took this, okay, all right, so here's the other problem with this situation. Let me open this in FreeCAD and show you where things go wrong. get rid of this. I don't have to save any of this. And, KiCad StepUp, import a board, and get, let me tell you where that board is. Git folder, badges, badge PC. Here it is. PCB edge not closed. Review. That's the first. It isn't complaining here. Try again and see if I need. Close this. And try again. Make sure this is the right folder that I'm choosing. Batch, yeah. Let's try. All right, PCB edge found, not closed. Okay. Let's try a third time and hopefully this works. PCB new. Edit.
Anul, can you try opening this in the 3D viewer? Maybe it will give you the coordinates where the issue is.
Actually, yeah, but no, I'm using the wrong footprint. So because I played around with this, so let me change your footprint identifier. Is this yeah. I think this should look now. I was messing around with this earlier, so that's why we told me. Maybe I'll talk about it once we have this sorted. But let's see if this works now first. Okay. So much more.
I think the one in your repo is okay. The one that's in the main repo does have that issue.
Okay. So which is
With
what
some
I
point
did.
after some merge. Yeah.
Okay, let me see if I have another backup somewhere. Let's see.
Is that your Git repo?
This is my local folder, not my Git repo. But this is actually what I cloned recently, so I might have overwritten my stuff with what's on the Git, which is funny because I'm sure I had this working a while ago. So, Heyman, here's the thing. If I do a 3D view, it actually doesn't complain at all, which is what is.
Oh, okay.
Yeah. Ideally, it should have complained here if the outline isn't closed.
Okay.
But it works here. I'm sure I haven't
Yeah.
edited the outline because it is
That's weird.
footprint actually.
That's weird.
Well, that's the fun part of doing the stuff online, man. Let's see. What did I change? All right, so let's not try and I'll try and see if I can figure this out later. But the way I would have, okay. So what I was trying to show was I lost my thought track on this. But let me just open up the other PCB first, so I can show it. 9 volt, KiCad. Here it is. Okay, so when you have your PCB edges as a footprint, as we have over here, And let's assume that the edges are closed and everything works and you can import it over here. The problem that happens is if you close down all of this board models and expand the board geometries, you will get this PCB compound, but you won't get this PCB sketch because obviously KiCad StepUp tools can't recognize a valid outline because it's a footprint and it has been added in one of the step models over here instead of being added in a board geometry. So that's the other issue with using, or rather pitfall of having edge cuts as a footprint. You probably should never do that. That's the point I was trying to put across. But if we can get this board to show up in FreeCAD, then it becomes really easy to make a square sketch around the edges, add these 4 mount holes, add this little slot in the middle through which the LCD flex cable goes, and have it fully constrained, number one. Then push it back over here. And once you do that, you would be able to have all of these hole locations pinned pretty precisely. Meaning, once you have that, you can then make your life easier when it comes to designing the, let's say, enclosure for the watch around the existing board. Because with this current situation, when I try to make the enclosure, which is, let me show you some, I don't know if I kept some blenders. These. CAD. I shouldn't have cloned the repo. That messed up a lot of stuff for me. I think I know where it is. Here. Yeah, I lost a lot of my work because I stupidly cloned the repo over the existing one and lost a lot of my work. So I'll have to go back in time and probably do it. Here it is. Sorry. Sometimes you get lost in your own. Here it is. So this is the enclosure that we came up with for the wristwatch badge. It's basically just 2 3D printed parts. That's the bottom part, the blue one, and that's the top part. These two are 3D printed. The lower PCB doesn't have any parts at all, and it was a good way to put all the advertiser or the sponsor logos on it. So nice real estate being put to use. So that's one surface of the enclosure. Then put some posts. You put in the lower part, plug in the top part, then close it from the top with these 4 screws, and you have this enclosure. So the trouble with making this CAD was that I couldn't precisely obtain the locations of the 4 centers of these 4 mounting holes, for example, or the position of the slot for the flat cable of the LCD and so on. So there was a little bit of estimation that went into this. It probably still works because it's not a huge error, but would have made things really easier if we had proper coordinates to start with. So just wanted to get that point put across when I was trying to show you this whole thing. So I don't want to waste time today trying to break my head on why this isn't importing into FreeCAD at the moment. Although I could try something else, maybe try a different version of FreeCAD. See if that works. Hopefully. This is version 18. We are running a snap version of 18, snap version 19. Taking longer than usual, just not a good sign.
Is this something you're going to show us? Oh, go ahead.
Yeah. Yep. Waiting for FreeCAD to load up. It's taking unusually longer than it usually should. So, not sure what's going on. Ah, here it is, finally. So let me try StepUp bench, KiCad StepUp. Open a board file. Go to Triple Badge PCB. Nope, doesn't work with this. So okay, let's not waste time trying to show you this. But this is what it was. How to define complex shapes. Okay, the other thing, which was on the agenda. Sorry, I missed that. Let me go back again. Sure. Is to move part locations between FreeCAD and KiCad. That's also pretty amazing. Let me start up this project again. Start changes. Okay, here goes. Okay, so here's the original 9-volt snap project, and let's say I import this in FreeCAD. Get rid of this project and let me import the 9-volt snap design, which is here with our new pentagonal shape. All the parts get loaded up. Okay, here it is. Okay. So if I drill down the project tree and look at step models, you'll notice that there are all of these parts that have been populated, capacitors, resistors, and stuff. Here's the main voltage regulator. And I want to move its location because let's say that this wasn't aligning up with a certain feature in my mechanical enclosure. Let's assume that this was a switch, for example, or an LED instead of just a voltage regulator. So I need to move the position of this so it matches up nicely with whatever is happening in my enclosure. So I select the step model for the voltage regulator under the step models, and in its properties for the placement, I drill down to position, and I can now set its XYZ positions to different values. So let's say I want to move it in the Y-axis, move it closer to the 2-pin header. So shifted it 2 mm north, for example. And I now want to push this location, new location, to the original KiCad PCB board. So that happens by using the second feature in KSU, which is known as push 3D moved models to the PCB. Once you do that, it asks you to save to that particular PCB. And before we do that, let's make sure we look at our board here, and you can see it's right about in the center of the PCB at the moment. But once we save this, it's replaced. Say OK. Close this. My project. I open it up in PCB new. And here goes. So here's the new position of the voltage regulator. So I moved the position of this device, this footprint in FreeCAD, and then pushed it to KiCad. And I can keep doing this back and forth and make, let's say proper alignment between the things that need to be fixed. Let me give you a quick demo of that as well. You can start using this itself. Let me import a step model. Okay, give me a moment here while I try and figure out. Lucky, KiCad, shelf, 3D, switch, headers, LCD, switch, SPS. Right. So I just got this. Just got this switch here. Turn it around a bit so it's kind of easy. And leave it here. Let's say here's a switch that you're trying to align. And this one is really just a FreeCAD trick. It's got nothing to do with KiCad. Let's say you have drawn a part of an enclosure. So I'll start off by creating a body, creating a sketch, choosing this plane, saying OK, and just make a big rectangle, let's say, like so. And, put a circle in it over here. Okay, I won't do any constraints over here. I just want to demo something quickly. Say close this. So that's my sketch. I pad it, and the reason it isn't working is because I put a hole in it, which KiCad, some FreeCAD, some other index. I delete this, close that, add the sketch through, let's say, 2 mm. Then take this face, create a sketch there, add a circle here, make it a pocket, like so. All right, so go to KiCad StepUp. This workbench. There, I'm looking for the aligner tools, which is okay. These are mover tools that I will do. Let's get the align. Give me a moment as I get rid of this. Close that. Okay. So this one is a workbench called Align Tools. It comes up over here. It's a standard workbench that you can add from the tools menu. And what it lets me do is take a step file like this and make sure that it is aligned with a hole like this, for example. So let me see if I can show how that works. first object is the reference. So just my first object. I select that window where the switch needs to be. Then I select this circle, which is where it needs to be. And then I select a line. There you go. So we now have this switch aligned precisely within this opening that I've made. And once I do that, I can then, push the position of this uh, footprint back to KiCad. Any questions on this? Something that I use quite often, where you want to align things within uh, existing features on a enclosure and push things back and forth between enclosure and PCB and back to PCB, back to enclosure. Okay. Questions, people? All right, somebody just give me a shout out to see if I've lost you all or I'm still here.
No, we're still here.
It's still
We're
here.
still
Tom.
here. Yeah. All right, so there was deafening silence. I was wondering, did I lose? Did everyone leave me alone? So
No,
that
it's really,
was a pretty
was really
quick.
cool.
That was a pretty quick rundown. So one is complex outlines pushed and pulled between KiCad and FreeCAD. The other is moving, let's say, footprint positions between FreeCAD and KiCad. And these are two things that you would use a lot when you're doing the CAD work on your PCB project. And based on experience, it really helps before you get started with your PCB layout to have a good idea of how you want it to be physically enclosed within an enclosure or whatever it is that you plan. Because after you've laid out everything, if it seems that you have to nudge your USB connector by another 1 millimeter, it's going to be a lot of work for you. So get component positions sorted out. And this is where I think a lot of your out-of-the-box thinking comes. Like if you take any part, let's take an Atmega surface mount package. You can technically, let's say, mount it with 4 positions on one side of the board and another 4 positions at the bottom, facing north, south, east, or west. If you don't mind 45 degrees, then you get actually 16 different ways of putting that device. So before you get started on your layout, it really helps to see which of these 16 positions would be most ideal in terms of routing and layout. Same thing with push buttons. I mean, or let's say a USB connector. Do you want it on the top face of your board or the bottom face of the board? And since these are things that are actually mechanical in nature, it helps to be able to go back and forth between KiCad, FreeCAD during this part of your design process before you actually start laying out the tracks. So kind of pretty handy that we can have this this workbench that allows us to collaborate between the two pieces of software. And since I found it so very useful for all of the work I do, I thought it would be nice to talk about it today. And, here it is. If I've gone too fast and you missed something, let me know. If there's questions you have, let me know. Otherwise, I think we have the live stream on YouTube, so you can go back and see how we did things today and figure out. Or I'm always there on Twitter or anywhere else if you have questions that need answers. So So if anything, let me know.
Could you show the putting the footprint from FreeCAD back into KiCad again?
Oh yeah, sure. Let me just hide this. Hide this. So let's take another footprint. Maybe we can do two things. We could actually move the regular.
It's not
Oh,
sharing
sorry.
anymore.
Sorry. Here goes sharing. Full screen share. Okay. So here, let's move the regulator back where it was. I think we nudged it 2 mm like so. And probably move the pin header somewhere else altogether. So here's your new location for the pin header. The way you move locations is in the project tree. You have this is your project, the board that you've imported. Inside it, there are 2 sub groups: step models and board geometry. The board geometry deals only with the outline of the PCB. So that's one of the things that we looked at today. And the step models contain the list of all of the step models that are populated on the board with their position. So you can select any one of them, and you can then change the property. So you might have to drill down over here. Like this is the placement drop down. Under placement, you have the position. Like so. You can also change the axis of the rotation of the device. This is 90. You can change it to 0, for example. Oh, that's the wrong pin header. So pin header is at 180. We can change it to 90, like so, for example. You can change the angle. You can change the position, like so and so on. So once you're satisfied that you have the footprint where you need it to be mechanically, then keeping that footprint, that step model selected, like right now, you'll see that it's green right now. You then do the push from FreeCAD to KiCad using this icon button here in the KiCad StepUp Tools workbench called Push 3D Moved Models to PCB.
Okay.
So here's a series of 4 let's say related icons. This one is push the sketch to the PCB edge. That means send it from FreeCAD to KiCad. Next one is push the location of the model from FreeCAD to KiCad. This one is pull the sketch from the KiCad board into FreeCAD. You can do that as well. And you can also pull a model location or a footprint location from KiCad into FreeCAD. So it works both ways. You can send and receive between KiCad and FreeCAD either the edge cut lines or the component locations or footprint locations. So these are the 4 locations, the 4 functions you use. So in this case, we are going to push the 3D moved models to PCB. Once you do that, you select the PCB where it needs to be pushed, click on Save, Replace. And here's an important thing. It says that StepUp Tools has found tracks on your PCB, which means since you moved the location of the footprint, you'll have to now go and fix your tracks, which is obvious, but it's a nice warning to have over here. And say OK. Hopefully, now when we go here, better close this and load it again. And here it is. This is the new location of my footprint header. The voltage regulator is still at its old position because although I have moved it over here, I have not pushed that position to KiCad. So I can do that as well. I can choose U1 and repeat the same function, push it, save, replace, say OK, and it needs to be closed and reloaded for it to work. There. So now the regulator is back to its original position. The pin header is at the new location. There's the 3D. There you go. So that's how you push and pull between the two programs.
Okay.
It's reached a stage where I think of KiCad and FreeCAD as really one. It is an extension of just one program. It's getting pretty nice features being to use this from both sides.
KiCad's already like 7 different tools anyway, so what's one more, right?
Exactly. That's what I was going to say. And another thing, okay, so when you fire up the KiCad StepUp tools, first thing is to look up the preferences because every workbench has preferences within FreeCAD. And that's the very first icon over here. When you do that, you get the preferences window. At the bottom is KiCad. And the important thing is to take a check of this. In PCB setting, PCB placement should be at grid origin or auxiliary origin, one of the two. If it is at the approximate PCB center, then you will not be able to push or pull either the edge cuts or the component locations, because obviously this is an approximate center of the PCB and it doesn't know exactly where in relation to that the part or the edge needs to be. So I was stuck with this for a while yesterday until I asked Maurice, the guy who does StepUp tools, about it, and he pointed me to this issue, and it is exactly what he said. I was stuck here at PCB center and I couldn't get things working for a while. I can't remember when I changed this, but apparently I did at some point. So grid origin and aux origin. So make sure that's that. And yeah, that's the only one setting to be aware of. The other one is also handy. Let me see where has it gone. Okay, is bounding boxes. Let's say you have a very complicated board with lots and lots of 0805 or 0402 parts, and when you're doing the CAD work, those are really non-critical in terms of mechanical work, and you don't really want to load them in FreeCAD. What you can do is tell KiCad StepUp tools which parts need to be loaded, and it will load only those parts and exclude everything else. So in this case, for today's demo, I've populated this list over here, and it starts with a list command, and then you list all of the the step footprints that you want loaded. So right now it's just a couple of them. Let me see. Go back. There's the 9-volt battery clip. That's the keystone part number 968. There's a 0805 LED. There's a 2-pin header, 1x02 vertical, and the voltage regulator, which is a SOT223 package. So these are the only 4 ones which are actual step files over here. This is one. This is the other one. The 9-volt clip is the third one, and this LED is the fourth one. The others, which are these parts, are just bounding boxes, which are not actual step files, but are placeholders for the dimension or size of that particular part. So this makes, let's say, if it's a very big board with lots and lots of step files, it might take a long time to load things. And using this filter, you can cut down the loading time and make things faster. So that's a nice setting within the StepUp tools for just loading some of these parts and not all of them. You can also blacklist certain parts, which means those uh, don't get loaded at all. So let's say you don't want to load any part which is uh, less than 1 mm tall. You can put that here, height equals 1 mm, and whatever component is less than 1 mm tall will not get loaded within the board when you fire up this import. So those are a couple of nice features within the StepUp tools. Preferences setting to when you're working with complex boards and lots of components, for example. So yeah, so that's that. There was one thing that I remembered, but then I immediately forgot. But when I remember, I'll come back to you guys. Any questions?
I have a kind of unrelated question to that.
Yeah.
So I'm pretty inexperienced with FreeCAD, and seeing your enclosure design got me thinking that in KiCad it's nice to be able to kind of just drop like a generic mechanical, let's say 3M or an M3 screw hole. But then seeing those standoffs in your enclosure got me thinking, what's the equivalent? Is there like a parts library, or do you kind of create like a custom standoff component or screw component?
Oh yeah.
To pair with those?
Yeah.
And sorry if you've already covered this in previous videos.
Oh, it's okay. You meant in FreeCAD, right? A library of.
Sorry, I might have used them interchangeably. Yes, in FreeCAD.
Right. So yes, there is a great library called, rather a workbench called Fasteners. Where is it? Here it goes. Here's a Fasteners workbench. And it does exactly that. It gets you all kinds of fasteners with different kinds of heads. There's Allen socket screws, there's slot screws, Phillips head, there's washers, there's nuts, and there is also a generic one that lets you kind of.
It doesn't look like you're sharing your screen anymore, by the way. Okay. I don't know if that was your intention.
No, it wasn't my intention. So I need to share the screen. Here it goes. So here's the fasteners workbench, and it gives you a whole range or array of fasteners that you can use with different kinds of screw threads, and you can also have nuts, washers. So that's one thing you can use for. Let's take a nut. So here's a nut. Once I place a nut, it is a generic M6 nut that it puts in, but once you click on it, you can change its values here. So let's say I want an M3 nut with, yeah, so that's an M3 nut. I'm trying to remember where I got the standoffs from, but there is a library which let me do that. Let me try and see if I can find that. All right, there isn't, but I can show you a quick way to do, let's say, headers. For example, it's not really very difficult. Go to the part design workbench in FreeCAD. You just hide the stuff that doesn't need to be. So let me make a body, and inside that body, I create a sketch and choose a plane, let's say XY plane. Okay. And I draw a quick hexagon, like so. Give it a radius of, I think it's 3.6 mm for 3x. I'm just guessing a number here for what should be the radius of this, make this line a vertical constraint, and now it's a constrained hexagon. I can see if it can take a circle as well. I'm not sure if this is going to work. It's worth a shot. There's a circle in the center which has a radius of 1 point. That's 1.5. That's your sketch, and then you just add it to whatever length you want, 25 mm. There's your standoff. Then you can make an, let's say you can make a linear pattern. What's it called? Pad 1. Pad 1. Okay. Choose how many instances I want of it. 4 instances over 100 mm. Long. Yeah, like so. Okay, the reason it's failing, if I recall well, is because it's got a hole feature inside it. For some reason, FreeCAD doesn't like that. But if this was a solid hexagon, would have worked. But I can make an array in a different way. Using the draft workbench. I can make an array here. Rectangular array. Here it is. Say 2 and 2, and set an x interval of 10 and a y interval of 10. It's not playing well with me today. So I just made an array yesterday, but I can't get it done today. I have to play with the numbers. But essentially, yeah, you can create solids and have them multiplied multiple times in either x or y direction. Hoping that gets you started. It probably doesn't answer you completely, but hope it's a start.
Yeah, that's good to work with. Thank you.
Yeah. Usually when I get stuck with FreeCAD, I found there's lots of nice tutorial content online in terms of videos, so that usually helps. Which is why I have poor memory. When I get stuck, I just look it up online and then figure it out. Probably 2 days later, I've forgotten it and then I have to try it all over again. But doing too many things makes your brain leak sometimes. All right, any questions, people? Anyone else wants to show off some new trick or share some experience with FreeCAD, KiCad? Or if there's something that you'd like to talk about, then I can set it for next Saturday. I'm open to topics too. Any of these. Looking to see if there's anything in the chat. Nothing on chat. Cool. So no questions.
I think something I would be interested in, and again, apologies, I know you've done multiple of these, so maybe you've already covered it, but for me, I think the biggest thing that would be really cool to see is start to finish taking a finished design, PCB design, and then making some kind of enclosure, whether that's 3D printed or milled or just where to place holes in extruded aluminum. type enclosure, just something like that, because I know a lot of my boards are naked, and just being able to come up with some means of enclosing them would be pretty cool to see.
Awesome. We can certainly do that. What I can do is set it up for next week. We'll take something simple, because sometimes it's like taking water from a fire hose. Too much. There's just too much of stuff going on. But we can keep it simple. We can take a project and see how we can build up a simple, let's say, 3D printable enclosure around it.
If there's CAD users who are Fusion 360 users, I can do the same thing. Take a KiCad PCB and then show how to create a 3D printed enclosure using Fusion 360.
Could do that. Although I'm wondering how I'm going to get Fusion 360 working on my computer.
No. I mean, I can do the Fusion 360 on mine. I was saying if we wanted to basically split the demo.
Right. Okay. Got you.
And we could even use the same PCB or something similar.
That'll be interesting, because it'll be a good way to compare how things are done in these two different CAD programs, and see which one maybe have some kind of a comparative, look at.
Exactly, because some people are familiar with one versus the other, but it's possible to do both.
Okay, so should we go with the simple PCB we saw today, the 9-volt snap thing? Because just a rectangular PCB. What I can do is make it slightly bigger, so we can add a couple of mount holes to it, and then maybe put a through-hole LED, so we can use that as an excuse to put a hole in the enclosure for the LED to stick out.
Good.
So I'll modify the designs a bit and keep things ready. I'll probably put it on GitHub so all of you can pull it before next week comes around. And then we have, both of us will have the whole KiCad project ready per se. And then we'll design an enclosure, one in FreeCAD and another in Fusion, and see how things go from there. Something simple that's 3D printable. It's essentially a lower part and an upper part, and the two screw together, something like that.
That'd be fun.
That would be great to see.
Awesome. Cool.
Appreciate it.
Right. This is nice, because that helps us set up next week's topic. I don't have to, think what we can do next week. But yes, and it's nice because I just heard our government has extended the national lockdown till the end of April. So we're still stuck at home for much longer. I hope all of you are keeping safe, though. All right, so if there's no questions, we can start signing off. It's been an hour and a half, and I think it's been pretty productive. If there are no questions, we can sign off and say our goodbyes. Oh, I see that's one.
Have a good day.
Thank you very much. Have a good one, folks.
See ya, guys.
Thanks.
Take care. Bye.
Till next time.
Also, I'll share the YouTube live stream somewhere on Twitter, so you guys can refer to it.
That'd be great. Thanks.
Okay, see you everyone. Bye.
Bye.